Okay, so number 29, denoted by the star, is also a calculator problem. It says the first derivative of a function f is given by this. So understand, this is the first derivative. How many critical numbers does f have? Okay, so it's talking about the original position. Well, I find critical numbers by taking the derivative and setting it equal to 0, or taking the derivative and seeing where it's undefined. So I can look at this, and what I'm going to do is I'm going to straight up see where the intersections occur. If I graph f prime of x, and I can see where it's going to be crossing that x-axis, I can see how many critical values I'm going to have on its original position function of f. Okay, so like I was saying, critical numbers come from when the derivative is equal to 0 and also when it's undefined. Okay, we can see that this will be undefined at x is equal to 0. However, it says the first derivative of the function is given by the following. It's on this open interval from 0 all the way to 10. How many values does f have on the open interval? So we are not going to include 0. Okay, this at x is equal to 0 says it also would be a critical number because it's undefined, because you can't divide by 0. However, we're trying to see on the open interval from 0 to 10. So we will not include this, just like we won't include 10. So from 0 to 10, let's see, in this case, we're only going to see where all of them are equal to 0. There aren't going to be any other undefineds. Okay, so we're going to go ahead and graph this in y1. We're going to graph it in y1 even though we know we're used to having y2 produce our derivative, the way we have our calculator set up. We're just going to interpret f prime of x from y1 because that's what we're given. Okay, so I will go over here and I'm going to go ahead and put the cosine squared of x. Notice how I'm going to put this into the calculator. So let me clear this real quick. Alpha y equals, it is going to be, the cosine squared of x is parentheses cosine of x, close for the cosine, close for the entire numerator, and it's going to be squared. This is how we put in cosine squared of x. Okay, we interpret this, but we put it in the calculator this way. And it's going to be over x, so over x, and then it's going to be subtracting 1 over 5. Okay, so alpha y equals enter 1 over 5. And let me go ahead and come down here and turn off these other graphs because I don't want them to graph. Let me make sure that there aren't any others. This was from that previous problem we did earlier in the review, and I will only end up graphing that first one. Alright, so zoom 7 I'm going to use for trigonometric functions. Okay, so you can use zoom 6 for standard, but zoom 7 you can also use for trigonometric functions. So you notice that it's hard to see where those zeros occur because you're on zoom 6. If I do zoom 7, since it's a trigonometric, they're a little bit more expressive as far as the jumps that occur, just slightly. Okay, so we're going to change our window just a little bit. We want to see between 0 and 10, and we see that these max and mins are pretty much occurring somewhere in between 3 and -3 perhaps. So let's go to our window. Let's put this as 0. Let's put our max as 10. And let's say that we want to have our y scale of, or x scale of 1. And we want to have these at -3 and 3. So that when we graph, it shows you just a little bit better as far as where these occur. Alright? So even so, these aren't stretched out that much. So let's stretch it out even more so we can see. So let's say -1 and 1. The window on the y's is going to be -1 and 1. And now we can see it stretched out just a little bit more and exaggerated to see how many we have. Okay, so this is 10. And it looks like we have 1, 2, 3. Remember, we're not including 0 because it was on the open interval. So 1, 2, 3 is what we have so far. We just have to verify with this to see if it matches up. So I can go and say second calc number 2, because I'm going to look for the zeros of the function. And I can say my left boundary is about here, and then my right boundary is over here. A little bit too much. And my guess, I don't have to do this, but if you wanted to, your guess or approximation is somewhere in the middle. Well, you'll see from the calculator, it doesn't have a sign change. So that did not end up changing in the fact that it didn't hit 0. Okay? So by looking at that, we're going to say that this is not a 0, and that these would be 1, 2, and 3 would be the answer. So we come over here, and B would be the answer for this question.